will also draw a histogram of the data. Okay, so we can start. I am going to get my whiteboard that way. Okay, so and I have both of them, and I'm going to minimize one of them. So I'm going to minimize my whiteboard. All right, so I'm going to minimize this one so I can see the other one. Okay, so this is the data given to us. They're all, none of them is 2 digits. Okay, and we are told to group it. That's what it means. Well, I want to group this data. But before I go ahead to group it, I want to eyeball the whole data and see what is the maximum number. I can just eyeball it and look at what is the maximum number. The maximum number is 7. Because it's not a lot of numbers, so I can just eyeball that. What is the minimum number? The minimum number is 0. If I really don't want to use eyeball it, I'll go to my calculator, and it's already in my L1. So I put it in my L1. So I'm going to go to Start, Enter. So you see this data is already in L1, but it's not arranged in ascending order. So let me arrange this data in ascending order. So I'm just going to go to Start, and I'll ask my calculator to sort it in ascending order. Sort ascending, which is number 2, and it's asking me where is the data. In other words, in which list is this data you want to sort in ascending order? It's in list 1, so I'm going to say it is in list 1. Okay, and it tells me done. It is sorted in ascending order. Okay, so right here, I'm going to go and see what is the highest number and what is the lowest number. In other words, what is the maximum number? What is the minimum number? I already know that the minimum is 0 and the maximum number is 7. But you know what? Just because the data could be 3-digit numbers, 4-digit numbers, this is just a simple data. So I see that the maximum number is 7, even from my, okay. And it's telling me that sample size is 11, I mean it's 20, because it's asking me for the 21st number. I will also check to make sure it is true. I can count the numbers. How many are there? All right. So you want to make sure that you know the count, sample size before you start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2, 20. So the sample size is 20. All right. So I know that the sample size is 20. Maximum number is 7. Minimum number is 0. I can quickly find the range by hand, because you see this number is actually so the range is maximum number minus minimum number. So the range is 7 minus 0. 7 minus 0 is 7. Okay, so whenever I'm trying to construct a frequency distribution table, I have to find the range, and I have to decide the number of classes I want. I actually want 4 classes. So I want 4 classes, which means I will divide the range by the number of classes I want. So 7 divided by the number of classes I want. If I divide 7 by 4, I have 1.75, but this number that I'm going to get is going to be the class weight. And it's not good for class weight to be a fraction. So I'm going to round it up. So you round up the class weight. Therefore, I will round up to 2. Therefore, the class weight of the frequency distribution I'm going to make right now is 2. the class weight or class size. Class weight. Remember what we are trying to do? We are trying to build a frequency distribution table. The first thing to do is to find the range and find the number of classes you want to get. I want 4 classes. Divide the range by the number of classes and round up. Even if you have 1.2, you still have to round up. Okay, so I rounded up and I have a class width of 2, so I can continue from there. So right now I have the class weight, I have the number of classes, so I can start to form my frequency distribution table. So let me do that. So I'm trying to make a frequency distribution table. I will have 4 classes already. I know that. So I'm going to do it here. I'm going to build, first of all, build 2 columns. They're not equal. So this is class, and this is frequency. Frequency. I already know that the total frequency is 20. Total frequency, I already know that. 20. Okay, so the smallest number is 0. I already found out that the class width is 2. So the smallest number plus 2 is the next lower limit. And the next lower limit is going to be 2 plus 2, which is 4. And the other next lower limit is going to be 4 plus 2, which is 6. And the other next, I think I have to stop here because I wanted 4 classes. 1, 2, 3, 4. 4 classes already. All right. Now it's time for me to get my upper classes, upper limit. I got my lower limits. So the upper limit must be one number lower than so the upper limit here should be one number lower than this. In other words, it's going to be 1 here. Why? Because the upper limit and the consecutive lower limit are not allowed to be equal. This must be 1 lower than this. Okay, so this one right here should be 3. Why? Because it should be 1 lower than 4. All right, so the next one is 5 right here. Why? Because 5 should be 1 lower than 6. And the next one is 7. And by the way, another way I can check is that the differences between the consecutive upper limits will be class width also. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. So, how did you know the class width is 2? And so, difference between consecutive lower limits is equal to class width. Difference between consecutive upper limits is equal to class width. So I have built my classes already. So the next thing I want to do is find the frequency for each class. So I'm going to pull up the data again. Let me pull that data again. This is the data right here. I want to minimize this data so I can. All right, so the first thing I want to do is find the members of the first class. The members of the first class must be from 0 to 1. So I'm going to count all the numbers 0 to 1. So 1, 2, 3 here, 4, 5. Is that it? So that's all I have. Okay, so I'm going to count again 1, 2, 3, 4, 5. So that's all the numbers from 0 to 1. Therefore, the frequency of the first class is 5. All right, so let me go and find the frequency of the second class. What's the frequency of the second class? Second class is between 2 and 3. So I'm going to count now. The first column has one of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 members of the second class, 11 members of second class. Therefore, 11 members are here. So the frequency of the second class is 11. I'm going to find the frequency of the third class. So let me do that. I'm going to pull that the data again. I'm going to count the members of 4 to 5, any numbers between 4 and 5. That goes 1 here. 1. All right, so I'm going to 4 and 5, numbers between 4 and 5. Let me, okay, this is another one. 1, 2, 3. That's it. There are only 3 of them. Numbers between 4 and 5. There are only 3 of them. All right, so therefore the frequency of the third class is actually 3. All right, so the next one is 6 to 7. How many members? How many members are in 6 to 7? So let me see. How many members are in the fourth class? All right, 6 to 7. There's none here. I just have 1 here. And that's it. I don't have any other member. Well, I know how to check myself. When I finish, I will add all of them up. If they're not up to 20, then I'm going to fix it, find what happened. So I didn't see any other number. I just have only 1. Okay, so I'll go to my table and say that I only 1 of them here. Okay, then I already know that the total frequency should be 20. So let me add up everything. There better be 20. There better be 20. So 5 plus 11 is 16. 16 plus 4 is 20. Okay. So we just made what is called frequency distribution table. That's all. This is a frequency distribution table. But it's not always going to be only this. Only these 2 columns are called frequency distribution table. But you can also be told to include the relative frequency. The relative frequency is the frequency of the class over total. And by the way, relative frequency is the same as probability, just in case anybody asks you. Okay, so the relative frequency of the first class is 5 out of 20. The relative frequency, I can leave it in fraction. I like to leave it in fraction, unless I'm told to leave it in decimal. The relative frequency of the second class is the number of the frequency over the total frequency. The relative frequency of the third class is the frequency of a total frequency. The relative frequency of the fourth class is frequency of class over total frequency. Okay, so we added the third column called relative frequency. In Unit 2, we shall baptize it probability. In other words, if there's a question that says, what is the probability that a number is in the first class? That probability is 5 over 20 or 25%. So somebody can actually ask you now, what is the relative frequency, or what is the probability that a number falls in the first class? It is actually the number of people in that first class over the total. All right. What if I'm told to include what is called the cumulative relative frequency? cumulative relative frequency, CRF. The cumulative relative frequency is the relative frequency of the class plus any one above. For the first class, the cumulative relative frequency will only be 5/20 because there is no class above it. For the second class, the cumulative relative frequency will be the relative frequency of this class plus the relative frequency of the class above. Okay, that's going to give me 11/20 plus 5/20. That is 16. Is it 16? Yeah, 16 out of 20. That is the relative frequency of the second class. Now, the relative frequency of the third class is cumulate all the frequencies from third class to the end. And so that is 19 out of 20. And what is the relative frequency of the fourth class? And the last class is 20 out of 20. And by the way, the cumulative relative frequency of the last class is always going to be 1, total frequency over total frequency. Always going to be 1. So very soon we shall explain that. We shall relate it to what is called the area under the normal curve, the probability, the total probability, and so on. But for now, I just want you to know, remember that the cumulative relative frequency of the last class is always going to be 1. So we already know a lot about this data. We know the class weight. The class weight is 2. So the class weight is 2. We already know. But suppose we are told to include another column. And the name of that column is class midpoint. Class midpoint. CMP, class midpoint. CMP, which is the same as class midpoint, is always the lower limit of the class plus the upper limit of the class. Like if I'm talking about the first class, the lower limit is 0, upper limit is 1 divided by 2. Therefore, the class midpoint of the first class is 1/2 or 0.5. I'm going to write fraction, 1/2. Let me find the class midpoint of the second class. It is lower limit of the second class plus upper limit of the second class divided by 2. And that is 5 out of 2 or 2.5. Okay. The class midpoint of the third class is lower limit of the third class plus upper limit of the third class divided by 2. So 4 plus 5 divided by 2. And that's going to give me 9 out of 2. By the way, if you see, you will notice that the difference between here and here is 4/2, which is 2. The distance between here and here is 4/2, which is 2. So actually, the class midpoint differ by the class weight. All right, so actually, I can add 4/2 here, and I have 4 plus 9 is 13, so I know that this is 13/2. So difference between consecutive class midpoints is the class weight. The difference between consecutive class midpoints is the class weight. Okay, so actually we have made a frequency distribution table. We included a relative frequency distribution table. We also included a cumulative relative frequency. We also included the class midpoints. So we know a whole lot about this data right now. Okay. Now I am going to clear some parts of this, and so that I can draw a histogram of this data on the right-hand side. So I am going to clear some parts so that I can draw a histogram. Remember, we are drawing a histogram, right? Organizing the data in groups, and then finding the frequencies. Then we found the relative frequencies. Then we found the cumulative relative frequencies. We found the class midpoint. For right now, I don't really need the cumulative relative frequency and the class midpoint. So what I'm going to do is clean them. I'm cleaning the right two columns so that I can draw a histogram of the data. I'm going to draw that by hand. After I draw it by hand, I will draw it by calculator also, which means you can actually use your calculator to do all these things that I'm doing by hand. Okay, but remember, because you're allowed to use your calculator, remember we have a test in about 2 weeks. You are allowed to use your calculator to do everything. So if you know how to use your calculator, then you are better off, because the test includes speed and accuracy. Your knowledge of knowing how to use your calculator is part of the test. Okay, so I want to draw a frequency histogram on the right hand side. Frequency histogram of the data that I just found. And I want to, this is first class, second, there are 4 classes. Okay, there are 4 classes, and I can use the class weight 0 to 1, 2 to 3, 4 to 5, 6 to 7. All right, then I'll eyeball the frequency column, and I see that the highest frequency is 11. So I will make the Y column, the Y-axis, to make sure that it includes the highest frequency. Actually, the horizontal axis are classes, so I'm going to write classes here, or class. All right. Because the highest frequency is 11, I can just subdivide 2, make it 2, 4, 6, 8, 10, 12. That way, my vertical axis will actually, this is 12. My vertical axis should include the highest frequency. Now I'm about to graph the histogram of this data. So I'm going to draw a frequency histogram of the data, frequency histogram. All right, so now I know that the frequency of the first class is 5. So frequency of the first class is 5, and 5 actually ends here. So I can just make my bar here and shed the bar. The frequency of the second class is 11. That should be the tallest bar because that is the highest frequency. So this should start from here. We'll give my crooked line. So the bar is the tallest bar. All right. So the frequency of the third class is 3. So the bar should be somewhere from here. And the frequency of the third class is just 1. So this, okay, so I have 4 bars. Why? Yes, I have 4 bars because I have 4 classes. I decided to have 4 classes at the beginning. All right. So what I just constructed is frequency histogram of the class. What if I'm told to change this to relative frequency histogram? If I'm told to change this to relative frequency histogram, all I have to do is change my y-axis to relative frequency. And how do I do that? All I have to do is divide each number by the total frequency. So the relative frequency of this is 2. I'm just going to put divided by 20. Why? I'm told to convert the frequency histogram to relative frequency. I can. So now I have a relative frequency histogram because I'm going to write relative frequency histogram here, relative frequency on the right hand side. Okay, I also could be told to draw a relative frequency polygon. What is a polygon? Remember when you were in geometry? A polygon is a closed figure. It's a plane figure. It's a closed by line segments. Okay, so how do I do it when I already have a relative frequency histogram and I'm told to superimpose relative frequency polygon inside it? Very easy. You mark center. For each bar, you mark a center. Mark a center for each bar. Then connect the dots. Remember, it's a closed figure, so I'm going to close it to the end here. It's a closed figure bounded by line segments. So my line, my black line, is the relative frequency polygon, because I could be told to draw a relative frequency polygon. So there it goes. I drew a relative frequency polygon there. What if I am told, remember the other day, last week, we were asked if data is skewed right or skewed left. What if I'm told to eyeball my histogram and answer the question whether the data is skewed right or skewed left? Well, if I eyeball this histogram, I can guess that this data is skewed right. But as a student who is in statistics, it's not enough to say that the data looks like it's skewed right. No, it's not enough to say that. You have to calculate the mean, calculate the median, compare them. If the mean is greater than the median, like we said last week, the data is skewed right. If the mean is less than the median, data is skewed left. And if the data is skewed, then you cannot use the mean to make a decision about the data. You must use the median. So I can already see that this data looks like it's skewed. But anyway, let me pull my calculator up so I can calculate the mean and the median. We already know how to calculate the mean and the median because we know how to do one variable start. So I'm going to turn my calculator on and I'm going to second quit from here and I'm going to clear. I want to calculate the one variable start of the data in L1. The original data is in L1. So I am going to make sure that it's there. That data is in L1 and I sorted it in ascending order. So I'm about to calculate the one variable start. After that calculation, then I'll know the value of the mean, I'll know the value of the median. I'll compare them, I'll find which one is greater, and that will give me a decision for skewness. All right, so I'm going to go to Stat, arrow to Calc, do one variable start, and it's asking me, where is the data you want to do one variable start of? My data is in L1. Remember, the data is in L1 is not a group data. Therefore, frequency list is nothing. Don't put 0 there. Just nothing. Don't put anything there. because it's a raw data. Now I'm the one variable stat. So I'm going to calculate. So I see that the mean is X bar. By the way, this data, they didn't tell me whether it's a population data or a sample data. So I'm assuming that this data is a sample data. And the mean is 2.45. So I'm going to arrow down. Arrow down. Remember that the median is the same as Q2. So the median is 2. The mean is 2.45. The median is 2. In other words, the mean is greater than the median, which means that the data is skewed right. So I'm going to show that this data is skewed right. So I'm going to draw it here. I'm going to show that this data is skewed right. So I'm going to show a skewed right data. Remember that skewed right means positively skewed. So the mean is greater, X bar is 2.45. Q2, or the median, Q2 is 2. So this data is skewed right. And because the data is skewed right, I can make decisions in this data with median. In a skewed distribution, decisions are made with median. But if the mean is equal to the median, then we know that the data is not skewed, it's bell-shaped. And we say it is normally distributed. So in a normally distributed data, we make decisions with the mean. Remember that the mean, median, and mode are called measures of central tendencies. Okay, so I have seen that the data is skewed right from my one variable data calculation. Okay, so the next thing I want to do is actually draw a histogram of this data using my calculator. So actually, I can draw a histogram of the data with my calculator. All right, so let me do that. All right, so statistical data can be drawn, statistical charts or graphs can be drawn with your calculator. So I'm going to do second y equals. So you see there are plots. I'll select plot 1. And if you see, there are 6 types of statistical graph you can draw. I'm going to arrow down. The first one is scatter plot. We're going to do that in Unit 2. The next one is, sometimes you can call it ogive or line graph. But anyway, we are looking for histogram. Histogram is number 3. But we can see what is the fourth one? The fourth one looks like a box plot. It's actually called a modified box plot. A modified box plot is used to detect outliers. If a data has an outlier, you can use a modified box plot to detect it. All right. The fifth statistical graph is the ordinary box plot. But that's not what we're looking for. The sixth one is the quantitative plot. It's also used for detecting outlier, but it does more. It also checks whether a data is normally distributed, a lot of things when you go to inference. But anyway, now we're going to go back to histogram because that's all we need. We select histogram if it's not selected. And my calculator is asking me, where is the data you want to draw a histogram of? I want to draw a histogram of the data in L1. And now I am going to zoom 9. Whenever you're drawing a statistical plot, you have to zoom 9. It's not enough to say graph, no. You zoom. Whenever you try to zoom and you see this argument, you say quit, get out of that. And you zoom 9 on the main screen. By the way, what does zoom 9 mean? I'm going to arrow down. What does zoom 9 mean? Zoom 9 means zoom statistics. In other words, you're telling your calculator to draw the statistical graph. Okay, so I'm going to zoom 9, and it drew the histogram for me. Remember, I asked for 4 classes, but I have 1, 2, 3, 4, actually almost 6 classes here. This class has a no members. But I need to fix the histogram that is drawn with my calculator so that it will look like the one I drew by hand. Because suppose I am told to use my calculator to draw a histogram with a class width of 2. Let's fix this. We go to Windows, arrow to X scale, and make sure that the X scale is the class width. Right now, the X scale is not the class width. That's why it gave us more classes than what we needed. So we're going to put 2 there. Anytime you change something in your Windows, you do not zoom 9 again, you graph. So I'm going to graph. All right, I have 4 classes. Makes sense. Makes more sense. I can actually ask my calculator to give me the frequencies. If I push trace now, trace, it tells me that the first class starts from 0 to 1, and the frequency is 5. See, I can actually ask my calculator. But you know, we did it by hand. But anyway, I'm trying to tell you that it can actually do everything with your calculator. If I arrow to the right, it gives me that the frequency of the second class is 11. Tells me that the second class starts from 2, does not get to 4. In other words, it starts from 2 to 3. The frequency of the third class is 3. The frequency of the last class is 1. So your calculator can actually give you the histogram, give you the frequencies if you know how to use it. All right, so see, that is how I can draw the graph of that data with my calculator. Okay. All right, so we calculated. Let's go back and see what we already calculated. We have done, we built a frequency distribution table. We included the relative frequency. So from today onwards, in fact, it's already in your test. You should be able to find the relative frequency of the class, of every class. You should be able to find, they can call it probability, find the probability of, and then you can do that. You can also be told to construct a cumulative relative frequency. You can be told to find the class weight of a given class. Note that the class weight here is 2. You can be told to calculate the class midpoint, and so on. Okay, so right now we are going to practice. Let's go back and practice a frequency distribution table with a data given to us where we're not given a raw data. All right, so this time I'm going to a data that is not even a raw data. I don't know where the raw data is. So I am going to be told to recoup the frequency distribution. So look at this data here. This data says create a frequency distribution table of the histogram. And by the way, we don't know the original data, but you could be given this in a test, and you're actually told to complete a frequency distribution table, find the relative frequency, find the cumulative relative frequency, find the 5-number summary, a lot of things. you should be able to do this. Okay, so I'm going to actually bring my whiteboard again and make it smaller. Actually, I'm going to do some cleaning. So let me do some cleaning. Tidy this up. So I can use this space to do my frequency distribution of that data given to me. It's a dump data because they didn't give me the raw data. They already manipulated it and did a frequency histogram. Okay, so I'm given a frequency histogram right here, and I have a frequency distribution table from it. From what even I have to construct a frequency distribution. So I am going to minimize this whiteboard so I can see. Actually minimize the, let me minimize the question. Okay. All right. So now I want to construct a frequency distribution of the data here. You will be given a question like this, and you will be expected to construct a frequency distribution of a histogram that you don't even know the original data. It's okay. You can do that. So let's do that. Okay, so I will construct, first of all, forgive my crooked lines. All right, so this, I'll write class here, and I'll write frequency. These two columns are called frequency distribution. Those two columns right there. But if you're told to include others, then you can do that. Okay, I will eyeball the horizontal level, and I will see the class also. So when I see the horizontal level, I know that the first class is 56 to 58, 56 to 58. The next one is 59 to 61, and I can actually continue from there without looking at my table anymore. 59 to 61, 59 to 61. Well, you see, if you look at this, the difference between consecutive lower limits is 3. Therefore, I already know that this is going to be 62. 59 plus 3 is 62. 61 plus 3 is going to be 64. 62 plus 3 is going to give me 65. Because why am I adding 3? I am adding 3 because the class width is 3. 64 plus 3 is 67. I don't even have to have all of them. 65 plus 3 is 68. 67 plus 3 is 70. And this is going to be 71. If I need this, 71 to 74. Probably don't need this. 73. Well, let me see if my table is right. Okay. Yeah, my table is right because all I need is the class width. When I know the class width from the first two classes, I can finish building the class. But let me make sure, yeah. So I can finish building the classes. So now I am going to find the frequencies from the data. So the first class has approximately frequency of 5. The second class has approximately frequency of 20. Third class, 35. So 20, third class has frequency of 35, and these are students. Why do I say it's 35? Because it's in the middle of 30 and 40. The fourth class has frequency of 40, and the fifth class has frequency of 25. So this is 40, this is 25. And the last class has frequency of, last class has frequency of 10. So after I build the frequency distribution table, the next thing I want to do now is actually find the number of students involved in this data. So how do I find the number of students? I will add the frequencies. What is the total frequency? So I'm going to find the total frequency right now. Let me grab this and pull it up a little bit. So what is the total frequency? So I'm going to add them up. And I can use my calculator if it's okay. So to find the total frequency, I'm going to clear this. And then the total frequency, I'm going to start from 25 plus 35. 25 plus 35 plus 40 plus 25 plus 10. And when I hit enter, I have 135. Therefore, the total frequency, summation frequency, is 135. Now I have built a frequency distribution table of the data. But that may not be all. I could be told to find the relative frequency. So I'm going to find the relative frequency of the data. So I make a column and I find the relative frequency of the data. All right, so create a column for relative frequency. Relative frequency. Remember, it's the frequency of the class divided by the total frequency. And also remember that relative frequency is the same as probability. Therefore, the relative frequency of the first class is frequency of class over total frequency. Relative frequency of second class is frequency of class over total frequency. I want to leave my answer in fractions like this, even though some of them can be simplified. This is 35 over total frequency. Relative frequency of this class is 40 over total frequency, 25 over total frequency, 10 over total frequency. Also, I could be told to create a column for cumulative relative frequency. By the way, remember that what we are doing is group data with quantitative variables. So cumulative relative frequency is what I'm doing here. All right, so in cumulative relative frequency, you cumulate the frequency of the class you are in plus the one above. There is no class above the first class, therefore, the cumulative relative frequency of the first class is 5 out of 135. The cumulative relative frequency of the second class is 25 out of 135. The cumulative relative frequency of the third class is actually 60 out of 135. The cumulative frequency of the fourth class is 100 out of 135. For the second to the last class is 125 out of 135. And the cumulative relative frequency of the last class must be 1, which is 135 out of 135, which is the same as 1. Remember, I told you very soon we shall say that area under the normal curve is 1. We shall say that the probability of the total probability of any probability distribution is 1. So very soon we shall explain to you what the cumulative relative frequency of the last class is always 1. So now we're done. We could also be told to create a class again called the class midpoint. We could be told to create this class, all these classes. Remember, the class midpoint is always the lower limit of each class plus upper limit of the class divided by 2. So lower limit plus upper limit divided by 2. And also remember that if you can calculate 2 class midpoints, you now continue with adding consecutive, adding the class width to consecutive lower limits. Okay, so for the first class, I have 56 lower limit plus upper limit of 58 divided by 2. If I get my calculator so that just avoid making mistakes, 56 plus 58, 56 plus 58, I got a number divided by 2. So the class midpoint of the first class is 57. That's all we need, but though. So that is 57. The class midpoint of the first class is 57. Now I can start adding the class weight because I already know that the difference between consecutive class midpoints is the class weight. And I already know that the class weight is 3. 57 plus 3 is 60. 60 plus 3 is 63. 63 plus 3 is 66. 66 plus 3 is 69. 69 plus 3 is 72. There you go. I have calculated all the class midpoints. And then